Hey there, welcome to this tutorial on positive diode clipper circuit. In this session, we're basically going to explore this circuit configuration and how it works and the practical applications that involve this circuit. So let's dive in. So what exactly is a diode clipper circuit? Basically a positive diode clipper circuit as the one we've got here. So a positive diode clipper removes or clips the positive portion of an input signal above a specific voltage level. We'll explain. So the required component for this configuration is your voltage source in series with your diode and a load resistor in parallel with these combination. Great. Now let's take a look at how this circuit functions. So you have the input waveform, that is a sinusoidal waveform that is now applied on the input, and when the input voltage exceeds the set clipping level that is set by this voltage source here, okay, the diode become forward bias, okay, and start to conduct. Now as a result, the excess voltage is then clipped. That is what you're seeing on the output there, preventing the output voltage from going higher than the clipping level. So that's in a nutshell how the circuit operates. Great. Now let's take a look at what's going to happen on the output of the circuit when this input here, which is an AC signal, we've got about 2 circles here, 1 circle and 2 circles. Right, just as a side note here, do you know when do we get this circle? Right, this is the output of an AC generator. You get this output here when the generator complete 1 revolution, basically 360 degrees rotation, and you're going to obtain this complete AC waveform at a particular frequency. Okay, that is a side note. So now at the first positive peak here, okay, so what's going to happen at the first positive peak, as you can see on the output here, the voltage is starting to rise. The voltage is starting to rise, and when the voltage get to those point, now we are assuming that this point is the point where this voltage increase to get above the set point of this voltage. At that point, the diode will become forward bias, okay, and as a result, the voltage will fall flat here, okay, and we're going to get the excess voltage is going to basically be clipped, okay. Now from here, we are now starting to go into the negative circle, okay. So the voltage, this input voltage, is now going to start to decrease to the negative, and it is now going to be less than this voltage here, okay. So at this point here, the diode is now going to become reverse bias. Now because the diode is in reverse bias and the input is a negative voltage, as you can see here, so what will happen then, the output will follow the input. That is why you get this output here that follow the input, okay. And this circle will continue again, start rising, and as this voltage become again bigger than this voltage, the diode will be forward bias, and we're going to get that excess voltage is going to get clipped, and the circle will continue on the negative circle. The output will follow the input. The output voltage on a negative circle when the diode is reverse bias is basically Vmax plus V. Now your Vmax is the amplitude here, okay, plus your V here, okay. So now if your Vmax is going to be, let's say, 10 volt, and this voltage source here is set at 5 volt, then you're going to have 10 plus 5, that's going to be 15 volt for an ideal diode. But for a real diode, you have to subtract the drop across the diode, so that's going to be about 14.3 volt. The diode positive clipping is mostly applied in area of noise reduction, basically in signal processing, and also in protecting sensitive circuit component from voltage spikes. You may employ these voltage clippers where you can set a reference voltage that any spikes that may come through might not go above the certain threshold that you can set, so it will fall flat, as you can see here. Now the other application will be shaping waveforms. As you can see, we basically shape this waveform, right, with clips, instead of having a sinusoidal wave form like this, we've got a waveform that is shaped like this. Now these will have a definite behavior in signal processing in communications network. And if I may just run this simulation here from applet circuit simulation. So I've got my input source here, which is an AC signal with an amplitude of 10 volt. Okay, so I've got a normal diode here, silicon diode, and I've got my voltage source set at 5 volt. Now as you can see, the output waveform is basically exactly as we've seen in the previous slide there. So if I stop this here, you can see the magnitude here of the negative peak is 14.3. So right, so this is basically the 10 plus the 5 volt here, but we have to deduct the drop across the diode, so that gives us about 14.34 of magnitude. And here at the clipping point, you can see there is absolutely no voltage here. It's about 171 microvolts. So these demonstrate how the diode positive clipping circuit shape the output voltage. Now please make sure you tune in the next tutorial, where I'm actually going to build a physical practical circuit. We're going to take a 1 kilo ohm resistor in series with a diode and a voltage source and apply an AC waveform and observe the input waveform versus the output waveform. Make sure you don't miss that tutorial. In summary here, positive diode clippers, they basically remove voltage above the specified level. The key components are your diode, your resistor, and your voltage source. We basically set the clipping voltage, and these are widely used for signal conditioning and protection circuit. Thank you guys for watching. If you found this tutorial useful, please make sure you like, share, and subscribe to CMTEQ channel for more practical and insightful diode topics. Until next time, cheers.